All of our math lessons, we begin with an anchor chart, and all the students sit on the floor. I teach the information. I use manipulatives whenever possible, so place value blocks, fraction circles, anything that can give them a visual representation of the math, because it's so abstract sometimes and they just don't see it. We try to learn the reasoning behind what we're learning and what we're doing, kind of the why behind the math, so that it sticks rather than, your teacher told you to do this. All right, boys and girls, we're going to talk about adding and subtracting decimals today. So if you'll make sure on your chart in your notebook that you have written down the standard and the title. Okay. Now let me show you something. Give me a thumbs up if this looks familiar and you've used them before. Okay. Now tell me what you know about using these to represent just whole numbers. So Evelyn, if I wanted to represent the number 235, how would I do that with these blocks?
The hundreds blocks.
And how many of those would you use?
You would use 2.
Okay, why would you use 2 of these to represent this 2 and this number?
Because one of those blocks equals 100, and you have 200.
Okay, does everybody agree with her that this has 100 in it? Yes. Okay, and then what would I use to represent my 3?
Longs.
Okay, and why would you use those to represent your 3?
They're 1/10 of the size.
They're 1/10 of the size, and there's 10 of these in here, and I know that 3, the value is 30, correct? Okay, and then what would we use to represent that 5? Just 5 of these, right? Okay, so we've talked about the fact that we can use these blocks to represent whole numbers, and we can also use them to represent decimals. When we represent decimals, we just need to decide which block is going to represent a whole. Okay, so if I use this block to represent a whole, think about what place is one place to the right of a whole number. Erin, what place is one place to the right? The tenths, that's correct. And so in that case, since this block is 1/10 of the size, this would represent the tenths place. So if this is my whole and this is my tenths, what place would this represent? Madden?
The ones.
If this is my whole, tenths, and what would be one place to the right of that? What comes after the tenths place?
100.
The hundredth place, that's right. Okay, and so we're going to draw place value blocks for these numbers here, and then we're going to talk about adding those together. So now let's look at an example where we're subtracting, okay? And so let's take the number 9 6/10, and let's say we want to take away from that 2 4/10. So let's look at how we could do that with place value blocks, and then we'll talk about what we need to do with our decimal when we're doing that. Okay, so if we were going to represent this number, let's again say that that flat equals a whole. So we use the same thing we used up here. I would use 9 flats to represent that number there. And then I would use 6. Dean, what would I use to represent that 6?
The long.
6 longs, that's right, because that block is 1/10 of the size. So I have 9 flats and 6 longs, and I need to take away from that. So this time, instead of actually drawing the blocks for this one, since we're not combining and we're taking away, we're going to use our pen and we're going to cross off the ones that we're taking away. So we'll start over here because we always start at the right side of a number when we subtract. So we're taking away 4 of these longs. So we're just going to put an X over those to show that we're taking them away. So there's the 4 that we're subtracting away. And then we need to take away 2 of our flats that represent our whole. So we'll just go ahead and cross off 2. It doesn't matter which 2. And now we'll look at what's left, because when we're subtracting, we're finding what's left over. And this will show us what 9 6/10 minus 2 4/10 would equal, what the difference would be. So we have 1, 2, 3, 4, 5, 6, 7 of our flats. And then we have 2 of our longs left over. So when we take 9 6/10 minus 2 4/10, we get 7 2/10. Let's look at it with the math and make sure that we get the same thing, because we always like to check when we do a picture. So if we take 9 6/10, we need to be sure that we're lining up our decimal. Can anyone tell me why I need to line up my decimal when I'm subtracting this 6 and that 4? And use your place value words.
So you'd have the correct place value subtracting from the correct place value.
Okay. And so when I'm subtracting this 6 and 4, what am I taking away, Darcy?
Tenth from tenth.
I'm taking tenths away from tenths. And if I didn't have that lined up, I would not be doing that. So we'll do 6 minus 4. Sam, what's that?
3 equals 2.
Perfect. And then 9 minus 2. And Gabby, what's that?
7.
7. Okay, my decimal point comes straight down, and that matches what we got when we did our picture. Okay. With the beginning of each unit, we take a pretest that's based strictly off the standards. And then from that, I can take that and determine, their levels of readiness. Okay, so my blue group, we've been talking about adding and subtracting decimals. And I know that we've talked about why we line up our decimal point. Can somebody tell me why we line up our decimal point? Gabby, why do we do that?
You'd be subtracting the tenths from tenths and the hundredths from hundredths.
Perfect. So we've talked about that, we've done that, and you're all very good at doing problems where you're adding and subtracting and you're lining up your decimal point.
Tori integrates technology on a daily basis. She participates in the Bring Your Own Learning device, and that's where students can bring in their smartphone or their iPad or their Kindle.
Today they were working on, each of the groups had varying levels of decimals, so just from basic addition and subtraction with a review of lining up the decimals. They had open-ended questions where they had to answer why we line up the decimals. So what we're going to do in a minute is you're going to take your devices and you're going to use your QR scanner, and we're going to walk over here to the bookcase, and there's some codes hung up there. When you scan it, a problem is going to come up. But what's different about these problems is these problems don't just have one answer, like 9/10 minus 3/10. These problems have lots of different answers that you could give. So when you're working it out and you're solving it, when you look at your neighbor's paper, they may not have the same answer, and that's because there's a lot of different choices that you could have. They're very similar to kind of the math journals that we've done. And so I want you to go over and scan it, and you're going to come up with a solution to each one of the problems, and then I want you to talk to the person that you're near about what you came up with and compare and see what you think about their answers that they came up with. Okay, does everybody understand? Okay, scan one, and it should bring up your problem. Got it? Perfect.
So that we subtract 10 of 10s, and if we have a whole number, we subtract wholes from wholes, and so we don't get the wrong answer.
What did we find when we subtracted and we had like a unit cube in the first number and we didn't have one in the second number, we were adding them? What did we end up trying to do when we didn't line up the decimal point?
We ended up trying to find out more than we had.
We ended up combining like a unit with a flat, which wouldn't work in what we were doing. Okay, you can go scan another one. Which one did you scan? Okay, and so in this case, what does difference tell you that you're doing? What does difference tell you you're doing in this problem? What kind of math?
I got subtract.
You're subtracting, okay, and so are they giving you the problem or what are they giving you there?
The answer?
They're giving you the answer, okay? And so you're looking for what might the two other decimals be that you subtracted that you came up with 6 and 53/100ths. Okay, so come up with an answer and then I want to come back and have you tell me how you came up with that answer. Okay, and so this is another one where what does difference tell you to do?
Subtract.
Okay, and so it says the difference is 6 and 53/100ths. What might those two decimals be that you subtracted to get that? So go see what you can come up with on that. Which one did you get? This one? Okay, the sum is less than 1. What might those decimals be? What did you get? Okay, and that's that one. Okay, and don't be afraid to try it, and if it doesn't work out, try something else.
1900 is the answer. Because they're both decimals.
Okay, the difference between two decimals is 1. So what does difference tell me that I'm doing?
Subtracting.
Okay, so I'm subtracting and end up with an answer of 1. So what might those decimals be that I'm subtracting then? Okay.
Yeah. And
Okay, but is this 1900ths? How do you read that? 1 and 9/10. Okay, and then what could you subtract from that you would end up with a difference of 1? 9 what?
Minus 9 to get 1.
Okay, like 9 wholes? Okay,
No,
1/10.
minus 9.
show me, do it for me. Because I think I know what you're saying. There you go. And so you didn't subtract 9 wholes. What did you subtract from there?
9 tenths.
9/10. And so taking away those 9/10, you got 1. Now see if you can do it where you have another answer where you're not just taking away what's in the tenths. See if you can do something where there's more than 1 in your whole number place. Okay, and that's correct. But see if you can challenge yourself to do something a little more difficult. I use music to transition because it gives them a cue. They know what to bring to the floor. They know which is math. With rotations as well, we use music. It gives them a set amount of time to rotate, and they know as soon as the music is over, it's time to be settled and it's time to continue the next rotation. Okay, good. Okay. All right, we're gonna go ahead and rotate. This group here, you can go ahead and log in Moto and find your code for your Nearpod. Okay. And then if you guys will go ahead and log into Khan Academy and get started. I gave you recommendations last night, so you should have plenty to work on. We use Khan Academy every day. It was something that I was introduced to last year, and it has just revolutionized differentiating instruction for my students. I'm able to find gaps in their learning that I didn't even realize existed that would cause problems for future things that I would teach them in 5th grade math, like subtracting and borrowing across zeros, something that I wouldn't realize as a 5th grade teacher that they could not do. Khan Academy is a free website funded by the Gates Foundation, and it covers topics ranging from just basic number sense with place value blocks all the way up through calculus. And the students work through and they master those skills kind of at their own pace. We use math journals every week. It gives the students a chance to write about their math, write their thinking out loud, and just really critically think. They normally will complete their math journal, and then they're always encouraged to talk about math. So as much as they can to talk with their peers, and then they usually do bring them up to me, and we look at it together also so that I can see their thinking and their thought process.
You got 103. Well, instead of you carried, there's a 1 there. It was 3 and 6100ths. You crossed off the 1 and said 10. Well, when you crossed off the 1, you carry 10 plus, and you add that 1, so it's 11, and 11 minus 7 equals 4.
With our groups every week, each group has a project per se that they work on, and that's a time for them to discuss mathematically their thinking with a partner or a group. And they work through it, and those are designed to be a little bit more challenging, give them a chance to apply the skills. They always relate back to whatever content we're using, and allow them to really discuss and work with their peers. And so the group was working on resodding a football field, and they had to decide what sod would be the best. They had to figure out the dimensions, and there were different rolls of sod that cost different amounts. And they had to determine which side would be the best to choose based on the area that they needed to cover and the cost that it would be. And then at the end, they had to write a proposal and explain which is the best, why, show their mathematical thinking, their pictures, their numbers, their words, and defend that. And then that group also would take that to the level of making a scale drawing of that, since that is my more advanced group.
What we need to figure out, I think, is the Creekview Booster Club is considering replacing the grass on the football field with a new and softer type, and there's been complaints of injuries, and principals asked them to investigate. So, and the local fans have agreed to volunteer their time and equipment to get the job done. And their only concern is the cost of purchasing the sod. They're looking for their best buy and the money. And so we need to scan the QR code. And then so we'll go to the website. And so this is going to bring up our types of sod that we can choose from. So we can either choose from Bermuda, Centipede, Zoysia, St. Augustine, or Bahani. And so let's just look at this, and it says the Bermuda is the most popular, and it provides a deep turf and handles the foot traffic well, and it requires full sun. So that was great that we needed to know. And the football field gets a lot of sun. So the Centipede, and it's also known as the lazy man's grass. And Centipede is their favorite choice for low maintenance lawns. It's especially good for larger lawns because it requires less frequent mowing. Centipede lawns do not require limbing and are the most shade tolerant of the warm season grass. So I guess Bermuda's the way to go.
Yes,
Right,
it has
so-
the best of everything.
Okay. So now I don't think we need this anymore. So let's go and look at the prices of the rolls and what it is. So let's turn our sheets over. All right. And the football field is 120 yards by 160 feet. So first we need to figure out how many feet are in a yard, and that's 3. So now we need to multiply 120 by 3. So that is 360 feet. 360 feet.
Nearpod is something new that I have found, and it just really engages the students. It can be used in a couple of different ways. We can use it for whole group instruction, and as I swipe my iPad screen, what shows up on mine shows up on their device or their computer screen. And so instead of just watching like a PowerPoint or something like that, they're actually actively engaged. And you can also add quizzes, polls, and different items in there for free. And then we also use it just for differentiation, because I'm always looking for ways to get information to them that's at their level and is different from what their peers are receiving. So we've done these before on note cards where we made a circuit with questions and then 4 possible answers. This time we're going to make it a little bit more difficult. And so if you will open up your file folder, just kind of leave everything else sitting there. So you have holes punched on both sides. And so if you're looking at it kind of like Max has it, one side would have the 4 questions and the other side would have 4 possible answers. And then when we run our foil, tell me about running your foil between them. What do you need to make sure you do?
That's the right answer.
Okay, and why does the foil have to connect those 2 holes?
So that when we connect the wire, it'll light up.
Okay, and why does it light up? Madden, can you tell me why it lights up if it's connected? What is it making?
A circuit.
It's making a circuit like we did in science. And so we want to make sure that the correct answer is connected to the correct question. Now, what would happen, Max, if I made them kind of overlap? Like I tape my foil on top of each other.
That would make me like it's not correct.
Okay, and what would happen when I try to light it up?
It won't light up.
Okay.
It would, but
It would light up another.
It would light up the other ones too, because they're connecting and they're making a circuit. So we want to be careful that we run our foil so that we're only connecting an answer and a question. When you make your questions, I want you to try to make some more difficult questions than just, like what is 2 minus 5/10, something simple like that. Try to make it a little more challenging. Yes, if you'll use decimals, you can use addition, subtraction, or multiplication. Okay, so go ahead and talk with your partner. Come up with a question first, write it down, and then I want you to start cutting your foil and make that first circuit. In 5th grade science, we learn about circuits, and so and they're very excited about that. We learn to build a circuit using a battery and a light bulb. And so we've used that in science with aluminum foil being a conductor and creating question cards. So we decided to try it in math. That should work.
that goes in there, and then let's make sure this one doesn't. Let's hold this one to here and to here, and make sure.
Well,
that
let's do the ones you want to light up. So which ones do you want to light up? The ones you
this
just
one
did.
to this one.
Okay, so let's go ahead and make your complete circuit. Okay. And I think that's in there, so you can let go of that one. It should stay. As long as he doesn't pull on it too hard. There we go.
I would do it right there.
Okay. Now touch it. There we go.
She is very adept at differentiating math, and that is something that a lot of people have taught whole group, and she's able to find different assignments that meets the needs of different learners.
I can stand up and teach an anchor chart and they all nod, and it looks like they all understand and they all get it. It's when I sit with them in a small group and we work together that I can really see what their understanding is mathematically. And I need that time with them to be able to know whether they're grasping the material and also to be able to differentiate how they learn it.
This math class is a lot different than any of the other classes that I've been in. It may be challenging, but you actually understand it a lot more than any of the other classes.
Boys and girls, if you will look up this way, if you'll just kind of set everything down for me for a minute. So today, when we did our anchor chart, we talked about adding and subtracting decimals, and everything that you did today within your Khan Academy and your math journals and all of your projects had to do with adding and subtracting of decimals. So this group here just finished your Nearpod. And Brighton, can you tell me what was in your Nearpod presentation that was similar to what we talked about today?
We learned how to subtract and add decimals, and that we need to line up our decimal. So if we're subtracting, we would minus Tenths from tenths and hundredths from hundredths.
Good, and so you saw that in what you did, and the same thing with your circuits and your math journals and your place value representations. We saw that we needed to have tenths with tenths, hundredths with hundredths, units with units, so that we were subtracting the same place value. So that's very, very good. Their faces, if they're a little bit worn out and they're a little more tired than I was, and they're excited to leave and come back the next day, then it was a success.